Hello guys, welcome to my YouTube channel. Today we will discuss about the Unit 2 of DSSM subject. The Unit 2 is single variable distribution. In single variable distribution there are two parts. The first part is part A, in which the important concepts are discrete random variable. Second one is continuous random variable. The other part is part B. In part B the important concepts are: first is binomial distribution, second one is Poisson distribution, third one is normal distribution, and fourth one is uniform distribution, fifth one is exponential distribution. Coming to the first part is discrete random variable. The first part concept is discrete random variable. Coming to the discrete random variable, first of all we have to know about the random variable. Random variable definition is: it is a function which analyzes the sample space. For example, tossing two fair coins, throwing two dice, etc. Here we have to know about the what is sample space. Sample space means total number of possible outcome. The formula for sample space for a coin is 2 power n, and for die is 6 power n. It is denoted by capital S letter. Let us understand with an example. Here toss a coin, such that S equals to 2 power n. Here tossing only one coin, that's why 2 power 1 equals to 2. Here the possible outcome is 2, that is head and tail for a coin. For a die we know the formula 6 power n. Here throwing a one die only, that's why 6 power 1 equals to 6. The total number of possible outcome is 6, that are represented as set of 1, 2, 3, 4, 5, 6. Now we have to know about probability density function. Probability density function also called as probability distribution function, and it is denoted by P of x. Let us understand probability density function with an example. Here two coins are tossed. We know that the formula is 2 power n. Tossing two coins, that's why 2 power 2. 2 square means we have the 4 outcomes in the sample space. The sample space is indicated as S equals to having 4 outcomes, that is 2 heads, 1 head, 1 tail, 1 tail, 1 head, and 2 tails. PDF probability density function is given by, here x equals to 0, 1, 2, because here x indicates head. Here in this outcomes we have 0 heads and 1 head and 2 heads. Coming to x equals to 0, 1, 2, the probability density function P of x is, when x equals to 0 we have how many outcomes? Positive favorable outcomes, having one only, that is 2 tails. That's why we are returning number of favorable outcome by total number of possible outcomes, that is 1 by 4. For x equals to 1 value, we have the favorable outcomes is 2 heads, tails, and tail heads, that is number of favorable outcomes by total number of outcomes, that is 2 by 4. For x equals to 2 value, we have 2 heads only 1, that's why x equals to 2 value we have P of x is 1 by 4. Let us understand the cumulative density function. It is also called as cumulative distribution function. It defines as adding to previous value to obtain new value. That is, let us understand an example. Here die is throwing, that is formula is 6 power n. Here dying one die, that's why 6 power 1 equals to, we get 6 possible outcomes, that is represented as S equals to 1, 2, 3, 4, 5. Here taking x value is 1, 2, 3, 4, 5, 6. P of x, that is probability density function, is for one value 1 by 6, two value 2 by 6. That is, here coming to each and every value only favorable outcome is only 1. That's why the favorable outcomes by total possible outcomes, that is 1 by 6, 1 by 6, 1 by 6. For getting a CDF, we have to add this value to its previous value. That is, let us assume here we are having 0. 0 plus 1 by 6 we get 1 by 6, and then next to adding this value to previous value we get 2 by 6. Like this we get 3 by 6, 4 by 6, 5 by 6, and 6 by 6. Here 6 cancel, we get one answer. It means if in CDF becomes CDF value equals to 1, then the CDF is valid. That is, we do the correct answer is correct. The important points in these topics are here. First point is discrete random variable avoid negative numbers. We have only the positive values in discrete random variables. It does not consist of negative values. The next one is the sum of probabilities of random variables equals to 1. The value should be equals to 1. This is the formula which we use always in the problem to solve the problem. The next one is the probability of x is in between 0 and 1, that is 0 less than or equals to p of x less than or equals to 1. The formulas in discrete random variable. In discrete random variable, the mean mu equals to summation x into p of x, whereas variance sigma square equals to summation x square p of x minus mu square, whereas standard deviation sigma equals to square root of variance value, that is sigma square value. Let us discuss an example problem. Here problem given that a discrete random variable x has following PDF. This is known as probability density function. Here probability density function is given as x column and p of x column. Here x values are 0, 1, 2, 3, 4, 5, 6, 7 and px of values of for 0 is 0, k, 2k, 2k, 3k, k square, 2k square, 7k square plus k. Here we have to find the k value and the probability of x less than 6. Third one is probability of x greater than or equal to 6. And fourth one is probability of 0 less than x less than 5. You have to find mean, variance, standard deviation. And eighth one is if p of x less than or equals to k greater than 1 by 2. Let us start the problem. Here we have to find the first one is k value. We know that summation I equals to 1 to n p of x equals to xi equals to 1. That means by adding these are all p of x values equals to 1. That is 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k equals to 1. Here k, 2k, 3k, 5k, 8k, 9k and 7k square, 9k plus k plus k, 3k square plus 7k, 10 square k square equals to 1. 10k square minus 9k minus 1 equals to 0. By calculating this equation in Casio, we get k equals to 1 by 10 and k equals to minus 1. Here minus 1 is neglected because it is a negative value. We take k equals to 1 by 10 value, that is k equals to 0.1. We get the value of k. Now we have to find the p of x less than 6. Here p of x less than means 6 means p of x less than 6 means the value 6. Here less than 6 means 0 plus 1 plus 2 plus 3 plus 4 plus 5. That is 0 plus k plus 2k plus 2k plus 3k plus k square. Here 2k plus 4k, 7k, 8k plus k square. By substituting k value 0.1 in this, 8 of 0.1 plus 0.1 whole square, we get the value 0.8 plus 0.01, that is 0.81. The value of p of probability of x less than 6 is 0.81. The next is p of x greater than or equal to 6 means p of x equals to 6 plus p of x equals to 7. The p of x equals to 6 value is 2k square and p of x equals to square value is 7k square plus k, that is 9k square plus k. Substitute the value of k 0.1 whole square plus 0.1, which gives 0.09 plus 0.1, that is 0.10. The value for p of x greater than or equals to 6 is 0.10. Next, finding the value of p of 0 less than x less than 5, that is x is greater than 0 and x is less than 5, which comes in between 0 to 5 is 1, 2, 3, 4, that is p of x equals to 1 plus p of x equals to 2 plus p of x equals to 3 plus p of x equals to 4. The value of p of x equals to 1 is k and p of x equals to 2 is 2k and p of x equals to 3 is 2k and p of x equals to 4 is 3k. By adding this all, we get 8k and substituting the k value is 0.1, we get the answer 0.8. For probability of x0 less than 5 is value 0.8. Coming, we are find mean. We know that mean mu equals to summation x into p of x, that is add, we are multiplying x value and p of x value, which gives, by adding these all values, and we get 66k square plus 30k. By substituting k value here 0.1 in this equation, we get the mu value equals to 3.66. Now we have to find variance. Sigma square equals to summation x square p of x square into p of x minus mu square. X square means x value, we have to square this x values square and into p of x values, that is as like follows. And by adding this and calculating in the Casio, we get sigma square variance equals to 3.11. Now the standard deviation SD equals to sigma equals to square root of sigma square, that is sigma square value is 3.11. We get SD equals to 1.763. Now we have to find the p of x less than equals to k greater than 1 by 2. It means we have the maximum value of k. By substituting k equals to 0, p of x less than or equals to 0 greater than 1 by 2. Here x equals to 0 value is what? 0. That means 0 greater than or equals to 1 by 2. No, it not satisfy. Let's k equals to 1. Substituting p of x less than equals to 1 greater than 1 by 2. Here x less than equals to 1 means 0 plus k. Here 0 plus k value is 0.1 greater than 1 by 2. That is not satisfy. If we take k equals to 4 value, p of x less than or equals to 4 greater than 1 by 2, by adding 0 plus 1 plus 2 plus 3 plus 4 values here, we get greater than 1 by 2. That means it satisfies the given condition. Therefore, the maximum value of k is 4. Let us say an example problem, another example problem. Here given that 2 dice are thrown, let x assigned to each point a comma b in sample space S. The maximum of its number, that given condition is x of a comma b equals to maximum of a comma phi. Here we have to find the probability distribution function, density function, mean, variance and standard deviation. We know that sample space equals to formula 6 power n. Here given that throwing 2 dice, that means 6 power 2 equals to 36 outcomes we get. That the following outcomes are like this. Here we have to find the PDF. We know that the x values for 36 outcomes is starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because here let us take x of 1 comma 1 equals to maximum of 1 comma 1. Here x of 1 comma 1 is this condition, giving to this condition. Here we are substituting a comma b comma value is 1 comma 1. The maximum value from 1 comma 1 is what? 1. That's why we are taking starting here 1, starting from 1 value. Now x of take 12 6 comma 6, we get the value how much is 6 only. Or guys, we have to take here x equals to 1 to 6 only, because here x of 1 comma 1 equals to maximum of 1 comma 1 is here maximum value 1, whereas x of 6 comma 6 equals to maximum of 6 comma 6 value is maximum value is 6 only. So we take here starting from 1 to and ending is 6. Probability distribution function PDF of p of x is for 1 value. What is maximum value for 1 is only 1, that is 1 comma 1. So here we write 1 by 36. For value x equals to 2, we get the value maximum value 2 is 1 comma 2, 2 comma 1 and 2 comma 2, that is 3 by 36. For x equals to 3, we get the outcomes is 1 comma 3, 1 comma 3, 2 comma 3, 3 comma 1, 3 comma 2 and 3 comma 5, that is 1 2 3 4 5, that is p of x is 1 comma 5 comma 36. For 4 value x equals to 4 value, maximum 4 value, we get 1 comma 4, 1 comma 4, 2 comma 4, we get 7 by 36. For value 5 we get 9 by 36, and for value 6 we get 11 by 36. This is the PDF for given problem. Now we have to find the mean. Mean means mu equals to summation x p of x. The value of x is 1 2 3 4 5 6 and p of x values are here. We such that 1 into 1 by 36 plus 2 into 3 by 36 plus 3 into 5 by 36 plus 4 into 7 by 36 plus 5 of into 9 by 36 plus 6 into 11 by 36. Here we take the 1 by 36 as common. We get the value 1 plus 6 plus 15 plus 28 plus 45 plus 66. By adding this value and dividing by 36, we get value is 4.4722. Mu equals to 4.74722. Now variance sigma square equals to, we know that the formula summation x square into p of x minus mu square. X square means we are squaring these values and into with p of x values. We get the problem like this. Here we are taking common 1 by 36 and calculating this all and minusing mu square. We get the sigma square value is 1.9716, whereas standard deviation is sigma equal to square root of sigma square value. That means square root of 1.9716, which gives standard deviation is 1.4041. Let us discuss another example problem. Here given that from 10 items containing 3 defectives, sample of 4 items is to be drawn at random. Let random variable x be number of defective items in the sample. Find PDF of x without displacement. Here given 10 items. In this 3 defective and 7 are good items. 3 defective items and 7 are good items. Here saying that 4 items are drawn at a random. That is, for 3 defective items we get 3C4 and for good items 7C4. The total items are 10 and we are drawing 4 items, that is 10C4. Here we have to calculate that find PDF of x without replacement. That is, x represent the defective items. That means let us take x equals to 0, means no defective. That means we get p of x equals to 0 is no defective, means 7 are goods. That's why we taking 7 good items and drawing 4 7c4 by total is 10, possible outcome is 10c4. For p of x equals to 1, we are taking one defective item and 3 good items. That means 3c1 into 3c1 plus 7c3 by 10c4. For p of x equals to 2, we are taking 2 defective items and 2 good items. That is, from 3 defective we are taking 2 and some 7 good items we are drawing 2 items, 3c2 into 7 plus 7c2 by 10c4. For x equals to 3, we taking 3 defective, we are drawing 3 defective items and 1 good item. That is, from 3 defective we are taking 3 random 3 and plus from 7 we are taking 1, that is 3c3 plus 7c1 by 10c4. Now the probability density function is PDF equals to x equals to 0, values 0, 1, 2, 3 by p of x. Probability density function is 7c4 by 10c4 value and 3c1 plus 7c3 by 10c4, 3c2 into 7c2 by 10c4, 3c3 plus 7c1 by 10c4. Yes, it is a probability distribution function. Hope you like the video. Please like, share, comment and click the bell icon to be notified every update from my YouTube channel. Thank you. Hello guys, welcome to my YouTube channel. Hope you people like the video. Keep supporting me by subscribing the YouTube channel and like, share, comment and click the bell icon to be notified every update from my small studies YouTube channel. Thank you guys.